In a humming data center on the edge of Silicon Valley, the fiber paths glowed with activity, rivers of information flowing to power databases, machine learning jobs, video feeds, and untold digital services. At the heart of this network was a problem. The world's growing hunger for data was outpacing the ability of the cables to deliver it. Jenna Lin, network architect, traced the tangled connections with a practiced eye. She knew every jump in data demand could send ripples through the infrastructure. AI simulations that required lightning-fast access to mountains of information, cloud applications syncing between continents in milliseconds, these realities demanded more from the network, constantly. As she paced the rows of humming racks, an email notification popped on her tablet. The subject: Acacia 800G ZR Plus and 800ZR, ready for next-gen interoperability. Jenna's heart skipped, a major update. In the briefing, figures danced over slides. Acacia's new pluggable modules promised 800 gigabits per second per wavelength, double what most current metro optical links could handle. Not only did they offer raw speed, but they came with a vital feature: Probabilistic Constellation Shaping, PCS, making networks more robust by dynamically adapting signal quality to changing conditions. Jenna imagined congested urban fiber routes, notorious for their variable noise, suddenly smoothed by this smarter digital control. The team at Acacia didn't stop at technical wizardry. The modules would fit both OSFP and QSFP-DD ports, physical standards that determined whether modules could snap into place in different vendor systems. In other words, no more vendor lock-in or forced, costly upgrades. The prospect of seamless interoperability excited her. This could breathe new life into existing infrastructure without the nightmare of forklift upgrades. But talk is cheap, and in the world of networking, proofs matter. The demo session arrived, streamed globally. Jenna watched as engineers energized the 800ZR modules in testbeds, first in OSFP, then in QSFP-DD. Their status lights blinked green, carrying simulated bursts of data hundreds of kilometers with no packet loss. In split screen, devices from another major optical vendor did the same, PCS negotiated between them, signals crossing the vendor boundary for the first time at this speed. Questions flooded the Q&A. How would this new reliability hold up in congested, noisy environments? Would 800G over ZR Plus reach metropolitan distances without regeneration? The engineers, cool and confident, referenced field results. 800G speeds, ZR Plus reach, seamless interoperability already proven on transcontinental routes. Satisfied, Jenna drafted her plan. This upgrade could transform her company's backbone, supporting the surging AI cluster workloads and keeping costs down. More bandwidth, fewer transponders, open interop between vendors, it all translated to better service for the cloud customers and the promise of scaling for tomorrow's unimagined applications. As Jenna sent off her plan to procurement, she envisioned a not-so-distant future. Thanks to innovations like Acacia's 800ZR and ZR Plus, with interoperable PCS, the digital arteries of their network would stay ahead of the world's boundless demand for information. Somewhere, AI models would run faster, users would stream without buffering, and, quietly behind it all, the world would remain connected at the speed of light.